Section 5.5, Integration by Substitution. We are going to spend probably 3 days on this, not because it's necessarily so hard, but because it is so important. And it can be kind of tricky sometimes to recognize what you are going to use for your substitution. But what does all this mean? So we've seen that some integrals are easy to solve because they simply reverse the differentiation process. But there's many others that do not follow our basic rules. In fact, there are integrals that can't be solved without technology, and others that can't be solved at all. So let's explore why. In the set of integrals below, there's one integral that can't be solved by hand. For each antiderivative, and find each antiderivative and determine which one can't be solved, and explain why it can't be solved. So let's remember that if I find the antiderivative, I can check my antiderivative by taking the derivative, and I should end up with cosine. So what can I take the derivative of that's cosine? The sine of x plus c. So, and if you look at this, the derivative with respect to x of the sine of x is the cosine of x. So this one must be the sine of x squared plus c. So let's take the derivative of the sine of x squared. And the reason I'm not putting the c here is because the derivative of any constant is just 0. So to take the derivative of the sine of x squared, we're going to have to use the chain rule. So the derivative of the outside, the sine, is going to be the cosine of x squared. And the derivative of the inside of x squared is 2x. But that's not what we have here. So this is not the derivative. We don't end up with 2x cosine of x squared. Oh, but we have the 2x cosine of x squared here. So this one must be equal to the sine of x squared, because if we take the derivative of this, we will end up with 2x cosine of x squared. Let's go down and look at the second set. In the second set of these integrals, again, there's one that can't be solved by hand. So I want you to find each antiderivative and determine which one can't be solved. So the derivative of what is 1 over x? If you look at your derivative card, or maybe you remember that the natural log of x, the derivative of the natural log of x is 1 over x. And we put the absolute value bars because you can't take the natural log of a negative number, so this just assures us that we're taking the natural log of a positive number. And again, if I look over here, the derivative with respect to x of the natural log of x is indeed 1 over x. So this one must be the natural log of x minus 3 plus c. Let's check it out. The derivative with respect to x of the natural log of x minus 3. So the derivative of the outside, the derivative of the natural log, would be 1 over x minus 3. And the derivative of the inside, the derivative of x is just 1. So, yep, that works. Let's try this one. This must be the natural log of 2x minus 3 plus the c. So the derivative with respect to x, again, the derivative of the outside, the 1 over 2x minus 3. And the derivative of the inside is 2. Well, if I were to take the derivative, if I could multiply this by 1/2, which means if I were to multiply that by 1/2, then these 2's would cancel. So I just need a 1/2 here. And now I have that. Okay, let's continue on. This one must be the natural log of x squared minus 3 plus c. And again, let's check this. One over x squared minus 3. And then the derivative of the inside is going to be 2x. And the 2 I can take care of because it's a scalar. It's just a constant. So as long as this 2 and this negative 1/2, I can multiply by a factor, make things bigger or smaller. I'm basically multiplying by 1, but I can't do that with x. So I don't have that. This one is the one that can't be done. So let's look at this one. The natural log of, well, somehow I needed that derivative, so let's just call this natural log of x cubed minus 3. And let's see what happens when I take the derivative of that. Let's see if I end up with that function that I'm taking the integrand. Let's see if I end up with that. The natural log of x cubed minus 3, 1 over x cubed minus 3 is the derivative of the outside. The derivative of the inside is going to be 3x squared, and that is indeed what I have. This one worked out too eventually. So there we have it. The derivative of the inside function, hopefully you've recognized, has to be part of the integrand. All of these that worked out, and recognize that the top two, the derivative of the integrand is just that 1 over, or the derivative of the inside is just 1. And the rest of these, this third one down, we had to compensate for that, and we'll get to how to do that. Now let's walk through one of these and actually think about what might we have to use for our substitution. So we're going to look at this function, the integral of x cosine of x squared minus 2 dx. Identify the inside function. Well, my inside function, hopefully you are good at this after taking derivatives and being able to recognize the inside and the outside. The inside function is x squared minus 2. The derivative of my inside function is 2x. And do you see the derivative anywhere? So my function is x cosine of x squared minus 2 dx. Do you see the derivative? Well, I see that I have the x, but I don't have the 2. So basically, since I would need to use the chain rule for the derivative, I need to have the derivative as part of the integrand so I can use substitution. So let's go up and take a look at how this works. We're going to let that inside function be my u. So that's x squared minus 2. And we're going to let du, well, we're not going to let du, but the derivative of that, du dx is 2x. And we're going to, in air quotes, solve this for du, and we're going to get 2x dx. Now if you recognize, I have an x dx. So let's go ahead and solve this for what I have. Since I have an x dx, divide both sides by 2. That's going to be the 1/2 du. Now I'm going to rewrite this integrand so we can see what the derivative is exactly. So I've got the integral of the cosine of not x squared minus 2. X squared minus 2 is u. And then my x dx over here is actually 1/2 du. So remember, a constant I can bring out in front of my integral, and I have du. Now I can take the integral of this, find the antiderivative very easily. I have 1/2. The antiderivative of the sine of u, of the cosine of u is sine of u, plus c. And then we just need to remember to go back and resubstitute in what u is, because our problem wasn't in terms of u. Our original problem was in terms of x. So we have the sine of x squared minus 2 plus c. So the big ideas here is we need to remember that if I have a composite function where I have an inside function and an outside function, I need to use the chain rule. This is just the chain rule. We're taking the derivative of the outside function, the f function, times the derivative of the inside function. And then remember that if I were to take the integral of that right side, so the integral of f prime of u of x times u prime of x, I would be taking the integral of the left side as well. And remember that the derivative and the integral undo each other. So that's just going to equal f of u of x. And so in order to take an integral, I need to have the derivative of the inside part of that function. And then an indefinite integral, don't forget your plus c. And so there's kind of 6 steps in terms of using the u substitution. The first step is to set u equal to that inner function. And then you're going to find the derivative of the inside function. So you're going to find du dx, and then you're going to solve. This really isn't a fraction that you can multiply by and solve, but you're going to solve, in air quotes, for du. Then you're going to look for the part of the derivative that you already have in your integrand, and you're going to solve for that part. So if you think about the problem up above, I had the x dx, so I solved that du equals 2x dx for x dx. Fourth step, you just need to rewrite the entire integral in terms of u. So there's not any x's, everything's in terms of u. Then you are going to integrate it, or find the antiderivative. And then finally, you are going to resubstitute and rewrite it back in terms of x. In terms of x, or whatever that original variable happened to be. So let's use this. First of all, my inside function, my u is going to be 3x minus 4. My du dx is going to be 3, the derivative of my u, which I can write as 3 dx. Now, I don't have a 3, but remember it's just a constant, so I could write dx is 1/3 du. And now I'm just going to substitute. I have the integral of not 3x minus 4, but rather u to the 5th, and then my dx is 1/3 du. Now this is a very simple one to take the integral of. I have my 1/3. The integral of u to the 5th is 1/6 u to the 6th plus c. Multiplying my fractions, I get 1/18 u to the 6th plus c. And now I'm going to substitute back in what u is. So 1/18 3x minus 4 to the 6th plus c. And this would be the final answer. Do you remember that the derivative of the secant is the secant tangent? If you do, then you'll recognize that my u is simply going to be 7x. So du is going to be 7 dx. Again, all I have is the dx, so if I solve this for dx, I'm going to get 1/7 du. And now I can do my u substitution. So the integral of the secant u tangent u, and then my dx is going to be 1/7 du. The integral of the secant tangent is just going to be the secant u plus c. And now I'm going to do my substitution. So I'm back in terms of my x. And this would be your final answer. For some problems, it's a matter of taking a pause and looking at the different parts. This looks like a really ugly problem. But if we look at this 4x to the 3rd minus 2, well, let's think about what the derivative of that would be. It would be 12x squared. I don't have a 12x squared anywhere. The next most complicated part is my exponent of the e, x to the 4th minus 2x. And the derivative of that is 4x to the 3rd minus 2. So my u is going to be that exponent, x to the 4th minus 2x. My du is going to be 4x to the 3rd minus 2 dx, kind of saving a step of solving for that du. And I actually have my 4x to the 3rd minus 2 dx. So I can just go straight to my substitution. I have e to the u du. The antiderivative of e to the u is just e to the u plus c. And now I'm going to substitute back in. So e to the x to the 4th minus 2x plus c. I'm going to stop here and do these last 3 problems in a short addendum video. So if you understand what you're doing, you don't have to watch that next video, otherwise there will just be 3 problems on it. And I'll see you in class.